Hello, Earth Science students. Welcome to the next unit in our Earth Science class. This is our second to last unit. We're going to be talking about climate. And the very first thing that we're going to talk about is Earth's seasons and how they change and why they change and that sort of thing. Make sure that you guys get your unit tests for the last unit, Earth's systems, done. Other than that, then there's just one other assignment that has to do with a cool interactive website. And other than that, let's get into it. Okay, so we have some basic definitions here. So the very first thing is the Earth is divided into hemispheres, the northern and the southern, and then the equator is what splits it right in the middle. So obviously we are in the northern hemisphere. Things like South America and Australia are in the southern hemisphere. The equator is the line of latitude that runs directly through the middle of Earth. Okay, it runs through South America here, through Africa, and through Indonesia, and goes all the way around the globe. Okay, the Tropic of Capricorn is the line of latitude running directly through the southern hemisphere. Okay, Capricorn is in the southern hemisphere, and the Tropic of Cancer is the one that runs through the northern hemisphere. Okay, and as far as what these determine, we'll talk about later about how they affect, how they're affected by seasons and that sort of thing, and why they get the names that they do. All right, so let's get right into it. What makes the seasons on Earth? What makes us have a summer and a winter and everything in between? There's a lot of misconceptions about what actually causes this. And I'm here to tell you first and foremost that it is the tilt of the Earth. So the Earth does not rotate perfectly straight up and down like this. It does not go around like that. It's actually at a tilt. And in fact, they've calculated it to be about a 23.5-degree tilt. Okay, and so sometimes the Earth is tilted towards the sun. So let's say the sun is over here. Sometimes it's tilted towards the sun, and sometimes it's tilted away from the sun like that. So in the summer, the North American hemisphere is tilted towards, and in the winter it is tilted away. Hey, another thing that happens is that we have an orbit, obviously, and from Kepler's laws we know that we do not orbit in a perfect circle, although it's very close to a circle, but there is a point in which we are closer and also one in which we are farther away from the sun. Hey, from the little picture up here, you can see that this tilt, for example, shows that the northern hemisphere is tilted towards the sun, and therefore we would be in summer, and South America would be in winter. Okay, this slide is just to remind you that there are other videos that I want you to watch, quick YouTube videos that have already been made that I want you to look through. They're in the same channel as this one. Make sure you guys watch through those. One thing, together the tilt and the orbit change how the sun hits the Earth throughout the year, and that, I think it's like a 30-second video, shows a very good simulation on how that exactly works. So make sure you guys check that out. Hey, so kind of a way to describe this is the angle of impact the sun determines the seasons. So if you imagine the sun being in the center and we rotate and we orbit around it. Okay, here in December, the winter solstice is between December 21st and December 22nd. North America, let me put a dot about where we are, somewhere over there. Hey, maybe you guys can see that, maybe you can't, I don't know. But we're over there. Okay, notice that when we spin around this way, okay, we are going to be tilted away. So even when the sun is hitting us, we're going to be like way up here on this top part of the globe, and South America is going to be really close. That's why in December it's really cold for us and really warm for South America. Hey, and then here in a second we'll talk about the autumn equinox and the vernal equinox, which is the spring equinox. And then you can see over here in June that we are actually tilted towards the sun. And so as we go around, we are constantly closer, not closer, I don't want to say closer because that's misleading, but we are tilted towards the earth, and that makes us have warmer days. Okay, so the solstice versus the equinoxes. So winter and summer solstice, this is when the sun reaches its highest or lowest point in the sky. For us, the summer solstice is when it reaches its highest point. That would be in June. The winter solstice is in December. That's when the sun is at its lowest. Okay, and then the fall and the spring equinoxes, the word or the prefix equa there does mean equal. These are the points in time where our nights and days are exactly the same. Okay, when we have a summer solstice, that is when we have the longest days. Okay, it goes to its highest point in the sky, causing the sun to be in the sky longer. Therefore, we have really long days. And then the winter solstice is when we have our shortest days. And obviously, by days, we mean time for the sun to actually be in the sky. Obviously, we have 24-hour days no matter what, but we're talking about the time that our Earth is actually lit up. Okay, so in the northern hemisphere, how does the sun in the sky look different in the summer than in the winter? And the answer to that question is that it is much, much higher in the air. Okay, we see it at a much higher angle than in the winter. It's at a much lower angle. It doesn't get as high in the sky. Due to that, okay, we get different kinds of angles on the rays that hit our Earth. Okay, so you'll notice that for our June, let me see if I can get my pen to work here. Okay, in our June, our angle right here, okay, right here, is going to be higher. Okay, so it's going to have a much larger angle, closer to 90 degrees than in December when the sun's angle is really, really low. Okay, so this may be closer to like 30 degrees or something like that in here. Okay, this may be closer to something like 75 degrees in June. Okay, one thing to notice is that the sun's rays, they hit a smaller area in summer because of how direct the angles hit us, and they cover a larger area in December when they're more spread out. Okay, so we don't get a lot of what we call direct sunlight in December, which also attributes to us not getting very much solar radiation, which causes heat. Okay, which is why we get a lot of cool temperatures and cold temperatures in the winter. Okay, here's just another depiction of what is happening. How does the sun look in the sky look different in the summer than the winter? Okay, if you imagine, I like this top graphic up here. It gives you kind of an idea of the different ways that the rays come in. So let's just take the northern hemisphere, for example. Let me get a color here. I'll just do blue. Okay, so let's say that we're about right here when we spin around and it's our daytime. Okay, notice that in June, we're going to get a lot of rays that are coming directly at us. Okay, and that causes things to heat up quickly. Okay, at the same location, okay, let me get a different color. Let's do orange. Same location. Okay, in December, notice that the rays that come in are going to be coming in at a much different angle and not hitting us directly hardly at all. This is what causes it to be cold because we don't get a lot of solar radiation. Okay, this is also an explanation for why the equator's climate is so unchanging. And I mean, if anybody's ever been to anywhere near the equator, even yeah, if you've ever been to Mexico or anything like that, they're closer to the equator. Okay, their seasons do change, but they do not change drastically as ours do. And that's because they get more closely the same direct sun rays throughout the year than we do. Okay, if you look at this bottom graphic, okay, these, let me move it down. These rays are going to hit the equator pretty similarly year round. Okay, they do change ever so slightly, but for the most part, they're going to hit at the same angle almost year round, causing the weather and the climate and the seasons to be relatively close to the same all the year long. Okay, so how is the southern hemisphere different than the northern hemisphere? So if you imagine, the only thing that's going to change is that when they are in summer, we are in winter. And when they are in winter, we are going to be in summer. Okay, and then also our spring and fall equinoxes are going to be mismatched. So when we have our fall equinox in September, they have their spring equinox. When we have our spring equinox in March, they have their fall equinox. So it's literally everything is just flip-flopped, and that is the only difference. They get the same rays, they get the same angles, they're all just at different times throughout the year. Okay, so for example, just to give you a good idea of what this looks like, in January, okay, so if you imagine in January, if I write this down, January in the southern hemisphere is actually the summer. Let me see if I can write this and it actually shows up. Okay, summer. And obviously, you know, for the northern hemisphere, for us, it is going to be the winter. Okay, in March, for the southern hemisphere, it's actually the fall or autumn. And for us, it's spring. In June, it's actually the winter for southern hemisphere. And for June, it's summer for us. Okay, and then in September, they have spring. And we have, and I cannot write because my face is right there, but they have the fall. Okay, or we have the fall because we're northern hemisphere. Okay, so all the solar energy is being exactly switched at all of those places. Okay, where they're going from summer, fall, winter, spring, we're going winter, spring, summer, fall. Okay, and then like I mentioned before, how is life on the equator a little bit different? And the only difference, excuse me, the only difference that there's going to be is that they don't get drastic seasonal changes. Okay, they get a lot of the same sun rays all year round. They don't get a whole lot of really cold temperatures where they get snow or anything like that. That's not going to happen on the equator and that sort of thing. So they're not going to experience drastic like summer solstices or winter solstices. So their days length is going to be relatively the same all year round. Whereas for us, you guys know that in the winter the sun is basically down by 4 o'clock, but then in the summer it's like up until 9 p.m. Okay, all kinds of things like that. Whereas theirs, they pretty much have sunset and sunrise at very similar times all year round. Okay, I have another video I would like you to watch, so make sure that you look for that one in the channel as well. Check it out. It talks again about the arcs of the sun on different days, the winter solstice versus the equinox versus the summer solstice and that sort of thing. Okay, this is just another graphic to tell you, to describe when things happen. So basically, declination is talking about the incline of the angle towards the sun. So if you imagine, we say that at the June solstice, this is for the northern hemisphere, at the June solstice, I can't see my cursor. At the June solstice, we're at our peak. Okay, that's when we're at positive 23.5 degrees in the air. And then we're at our lowest down here, winter equinox, when we're at negative 23.5. And then right here at 0 is when we get the March equinox and the September equinox right here and right here. Okay. And so that's kind of the course of action of the sun's angle in the sky as we go through our year. And then you'll notice here at 0, I also have the equator labeled, mostly because it describes like right where the sun is going to be about the same all year round. This is more of a drastic view in the sky of the inclination and declination than the equator would get. Okay, so graphing the sun angle. I like this graphic down here at the bottom. It kind of shows you the path of the sun at certain times over the course of a year. And it also, what we're trying to explain here is why then, because the sun has this path, is why we have summer and why the southern hemisphere has winter and that sort of thing. So if you imagine, we get energy from the sun when it's up all the time, constantly. Okay, so the longer it's up, the more energy we're going to get. Therefore, the more heat is going to come to wherever we are on Earth. So if you imagine, this yellow line on the top is going to be during the summer, and that's going to tell us how much solar energy actually comes to Earth during that time. Whereas the one on the bottom, that looks like something like brownish red, maroon, something like that, is going to be in the winter. Notice that it's not in the air very long, so it gets very little heat to the Earth, making us very, very cold during that time. Okay, so graphing the sun angle, I'm going to try to do this for you, and hopefully it'll make sense. If you want to pause the video and see if your answers match my answers, go for it. Okay, I'm just going to kind of explain what the angle is going to look like during different times and places. So let's look. Let's start in the southern hemisphere. I'm going to do it in red. And I'm not going to be exact with my degrees. So what we're talking about here with 90 degrees all the way to 0 degrees is the angle that the sun's rays hit the Earth during these times. So for example, if it's right over the equator, it is going to hit it right at 90 degrees. Okay, and so for example, where's my cursor? Right in March and in September on the equator, that's when the sun is directly over the equator. So it's going to hit at very, very close to a 90-degree angle. Okay, and so what happens is basically then it's going to, I said I was doing southern hemisphere first, but I'm not. Basically, in December, it's going to go down a little bit. Okay, and in June, it's going to go down a little bit because it's not going to be directly over. And it's going to look something like this. Okay, so what we're talking about is like if I have the equator there, like this is the Earth at the equator, and I have the sun here. When the sun rays come down straight like this, they intersect at a 90-degree angle. Okay, during December and June, the sun does not go directly over. Instead, it's a little bit higher or a little bit lower. So on that same spot, it's going to hit there, and it's going to hit there, and their angles are going to be relatively similar. Okay, again, remember that the equator does not change that much, so the angles don't change that much. Now, for southern hemisphere and northern hemisphere, we would expect these angles to be pretty much exactly opposite. So if you imagine, let's do northern hemisphere actually, because I'm guessing you guys are more familiar with the seasons in northern hemisphere. So the first thing that you need to know, in December, that's when we're in winter. So that's when the angle is really, really low. It's hitting, so the sun is really, really not high in the sky in winter. So when it hits something, the angle is low. Okay, in March, it's actually going to be at directly a 45-degree angle. Okay, and also it's going to be the same. Remember that these times, March and in September, my dot's a little off, mostly because my face is in the way, but either way, in September and March, that's when we have equal days, and so that's when we have a perfect 45-degree angle in the sky for the sun. And then if you imagine, see if I can find my cursor again, in June is when it's going to be the highest. Okay, that's when the sun's going to be highest in the sky. And so we have this kind of curve. And if you imagine, September is then going to lead into another December, and so on and so forth, and it'll go up and down and up and down. Okay. Now, for southern hemisphere, we're going to have the same March and September, but these are going to be opposite. So in December, they're going to have their summer, and in June, they're going to have their winter. So it's going to look something like this. And then again, it'll go up and down and so on and so forth. Okay, so hopefully that makes sense about where the sun is in the sky. So if you're asked on the quiz, you know, in the northern hemisphere, it's summer. Do we expect it to be high in the sky, low in the sky, middle sky? You can say that it's high in the sky because it's summer, or vice versa if it's winter, and so on. Okay, so if you've ever heard of, for example, like in the northern parts of Alaska, if you've ever heard of during the winter when they get literally like maybe an hour of sunlight, okay, this tilt is also why. Okay, so here's kind of a graphic of this top one here, okay, this one, of where the sun is illuminating at any given point. Okay, this is when the sun, or when the earth is tilted away. Notice how even as we rotate and this moves straight across, there's gonna be places up here that see virtually no sun. Okay, so for example, in I'm guessing this is probably Alaska or northern Canada or something like that. Okay, this is at almost 1 o'clock in the afternoon, and the sun is only 2 degrees above the horizon. Okay, the sun's about to set and it's 1 p.m. Okay, that's what happens when you go farther and farther north. Okay, in the winter, is you're going to get less and less sun. Okay, and that's also why latitudes are given out in degrees. So if you say, oh, you live at 23 degrees north latitude, okay, that tells you a specific thing about how the sun interacts with that location. So for example, during this time, the winter solstice, remember that is when in the southern hemisphere it's highest in the sky, and in the in the northern hemisphere it's lowest in the sky. The sun is directly over about 23.5 degrees and that has to deal with the tilt as well. 23.5 degrees south, and then obviously that switches when we're in summer and they're in winter and that sort of thing. But I just wanted to give you a nice depiction of why there's certain places that see very, very little sun in the winter. And again, that all has to do because of the tilt. Okay, things that do not make seasons. Okay, so remember that we talked about the perihelion and the aphelion. In January, we are actually closer to the sun than we are in July. It is completely based on the tilt of the Earth, okay, and how much solar radiation travels to Earth at that place. Okay, so make sure, don't get it confused and think that just because we're closer, we have to be warmer. That is not the case. Okay, what are some ways to change the flow of the season? So the Earth's tilt ranges between 22.1 and 24.5. On average, it's about at 23.5. Recently, I mean, it doesn't change very much from year to year. I know I looked it up earlier. I'll have to get back to you guys on how long it takes to go from one extreme to the other extreme, but it's hundreds of thousands of years. But anyway, the more tilt, the more extreme the seasons, because if you imagine at 24.5, 1 full degree, we're going to be closer to the sun, and actually it'll be up. The sun in the summer will be up a lot more, and therefore we'll get a lot more heat, so we'll have hotter summers. And then also, if the extreme tilt is away, we'll have even less sunlight, and it'll be even more cold. And if you imagine the people in the north hemisphere will have even less sunlight, they'll maybe not even get any at all, that sort of thing. But those things can affect the seasons as well. All right, that is all I have for you. Make sure you watch those 2 other videos that I talked about in this one. They're listed below in the same feed. And as always, thanks for watching.